So I have my IntelliJ open in presentation modes. Let's solve this problem here. Okay, and let me take the same method name as given in lead code. We'll mark it as private static, and this one is final to make it immutable. Now, as we have discussed here, that we start with we create a DP array, and we start with our last index first, and we keep on moving to the 0th index. That DP0 would be our final solution. So let's create that DP array, and it would be start with s.length plus 1. 1 is for base case. I'll show you where. Now let's start from the last index first, right? So I'll start with for I. It should be s.length minus 1, because if length is 3, then if length is 3, then this index would be 3 minus 1, 2. We start with 2. This is from where we started, and dp should be greater than equal 0, because 0 is our final solution. It should be I minus minus. Okay. So we first of all we check that if we are just treating one single digit, the only condition we need to check is that whether it's between 1 to 9. If it's 0, then it would be 0. If it's 1 to 9, then the number of ways is 1. This is our base condition for only one digit to check. So if s.charAt I equals 0, in that case, the dp of y would be simply 0, because 0 is nothing, is never matched with anyone. It starts with 1. A starts with 1. Else, if it's 1 to 9, as we have checked in other cases, like here it should be dp would be dp of I plus 1. So dp of I would be dp of I plus 1. But hold on here. If we are starting with our base case here, right, 6, we don't have anything here after the last index of 2. So in that case, we cannot use this formula unless we specify our base case or edge case when start with here. So I will just do for our base condition, I will just mark the last index as 1, so that this formula works for 6. I mean the index of dp of 2. It should work if you're using this formula. So that's why here I will mark dp of s.length is equal to 1, so that this works when we start with I is equal to s.length minus 1. In that case, it will take this formula as 1 as our base case. Right? This is our edge case that we already covered. For the other digits like dp of 1 and dp of 0, we already have the value calculated here, so it should be fine. Only we need this to be available for our last index where we start from. Okay, so we have done this. Now let's go to the logic that if okay, so if we are say here considering 2 and 6, right? We calculate a formula that it should be dp of I plus dp of I plus 2. But we need to check that whether I plus 1, if we are treating the whole I plus 1, it should be less than string's length, because we don't want the overflow conditions. And now we had to check here we are checking 2 digits at a time, right? So that's why I checked that I plus 1. If we are at I here, it should I plus 1. It should be within the range of s.length. If it's say if I am at the last character for 6, there is nothing. I plus 1 would be overflowing it. So this condition will not go for our DP2 condition. It will only go with DP of 1 and DP of 0. This condition would be true. Now, and we also check that the first digit, so if we are considering 2 and 6, this digit can be only 1 or 2. If any other digit, then it will fail. So we have to check here that I will just mark it in a separate line, that if s.charAt I is equal to 1, right? So if this is 1, then we already checked that s of I plus 1, like this digit, one's digit can be any number 0 to 9, so it would be all valid. So that's why we don't need any check further for this part. It can be any digit. But if it's 2, right, then in that case we have to check whether, if this is 2, then only in that case we have to check whether it's between 0 to 6. If it's 7, 8, 9, then it will fail, right? So here we'll do the same thing. So if this is or, we'll remove this, and s.charAt I equals 2. Right? We will also write it in a separate line because this condition is already done. For 1, we have already done. Now we have to check whether if it's 2, only in that case, we have to check whether the character of I plus 1 is 0 to 6. Or it should not, or in other words, it should not be 7 to 9, right? Seven to 9. So it should not be equal to 7 to 9, or it can be only between 0 to 6. So let me put the same thing here. So if the character at I is 2, and I'm just messing with this, and s.charAt I plus 1 is not equal to 7, right? Or I can just write it as equal to 7, and I will mark it as not outside. Okay, or just bear with me. I mean, we are just we'll check all those brackets later on, but let me write the formula first. So or s.charAt is equal to 8, right? And I will just do this is equal to 9, and then this is from here till here. So I will treat it again in one bracket, and then it should be not outside, right? Yes. And this covers for s.char is equal to 2, and now we have also got s at char equal to 1, so it will be one more bracket, and the final bracket would be this, covering this whole if condition, right? And then only we will consider as dp of I is equal to dp of I plus dp of I plus 2. Now let's revise this again. This is the first condition. I will again, it's better to mark it in brackets so that's very clear. So this is our first condition, that we don't overflow, because here we are considering 2 digits at a time. So here we'll see that if I plus 1 is within the range, and then we check that whether s.charAt I is equal to 1. In that case, we don't need to check I plus 1 because it can be any number from 0 to 9. Only when it's 2, only in that case, we are checking that whether it should not be 7, 8, or 9. It can be 0 to 6. This is all we have done. This is not condition at outside. This signifies this one as condition, as not 0 to 6. And if all these conditions match, then only we do dp of I is equal to I plus 2, as we have reduced this formula here. That's just all about this formula. There was, you just like mess around with this brackets here, and this would be all done. So now we have to just simply return dp of 0, which is our final solution. Now let's run this for our base case num decodings, and we will use the same as we shown in the example. I run this. So it gives me the correct answer. Let me copy this code and submit it in LeetCode and see whether it works there. Let's make some space here. As there was a small bug here, so s.charAt should be 0, not 1. Okay, not 0 digit, but it should be 0 character. Let me again run this to ensure this is all good. Okay, it's correct now. Now let me copy this. Just copy this here, the correct one, and then let me submit it here. Okay, so this works fine. So let's quickly check our time and space complexity. So the time complexity would be, because we are just using one for loop here, right? So it should be O of n, because there's only one for loop that we are using. We are just iterating through whole DP array once. And similarly, for the space complexity, we are just maintaining one DP array of 1D of one dimension. So it would be again O of n. So this is time complexity and space complexity, same as O of n. So guys, this was all about the decode waste problem. In the next video, we will solve our next very interesting problem of unique paths, which would be our 19th problem in this tutorial series. I think this problem is also very interesting, and it's been being asked in various companies. And it's the most important thing is that it's a very interesting video game type of problem. So let's solve this problem in our next video.